U.S. Oil presents the process of Kansas shallow oil well drilling. To prepare for drilling, a water source must be available. To provide water for the drilling rig, 2 pits are dug next to each other. Each pit is approximately 6 foot by 10 foot and 8 feet deep. A small break is dug between the walls to allow water to circulate from one pit through the drill rig back to the second pit and then return to the first pit. Once the pits are dug and the drilling rig is on site, ready to drill, water is brought into each pit. Once the drill rig, water source, and other infrastructure is in place, a drill bit mounted on the end of the drill pipe begins drilling the well. The well is initially drilled to a designated distance. The pipe and bit are then removed and surface casing is inserted into the hole. The casing is then secured into place by pumping cement through the casing and through the shoe at the bottom of the hole. The cement barrier and steel casing prevent any contamination of fresh water or aquifers. Once the casing cement is set, drilling of the hole continues by drilling through the wiper plug, shoe, and cement at the bottom of the well bore and on toward the targeted zone. Throughout the drilling, a mixture called mud is pumped down into the well through the drill pipe. The water and mud serves to keep the drill bit cool, carry the cuttings to the surface, and provide hydrostatic pressure, prohibiting formation fluids from entering the well bore. As drilling approaches the depth of the target zone, a U.S. oil geologist is on location. He uses a simple tool to capture samples of the cuttings. He analyzes the cuttings, identifying the downhole lithology and any presence of hydrocarbons. As the well is being drilled, he provides real-time information to the operator and rig personnel. During this phase of the drilling, anticipation is high for hopes of a show. A show is an oil industry term used to signify visual signs of oil during the drilling process. There are a few shows that may occur. One is an oil bleed that can be seen as oil bleeds from the drill hole and into the pit. Another type of show is seen from oil-covered cuttings that are pushed up from the hole and captured by a seining stick. Although having a show is promising, the presence or lack thereof does not indicate the viability of a well. Once total depth is reached, the drill pipe and bit are removed from the well bore one last time. The information gathered from well logs is highly valuable in determining whether to complete a well or not, and therefore U.S. Oil chooses to log each well drilled. The logging tool is lowered to the bottom of the well on a wire line. As the tool is pulled back up the entire length of the well hole, data is continuously gathered. This data is converted into an electronic graph called a well log, which represents the geologic properties of the layers below the surface at any given depth. There are multiple log tests that U.S. Oil uses to determine the viability of a well. One such tool is the gamma ray tool, which measures any radiation emitted by the rocks. Rock with lower amounts of radiation is called cleaner rock, such as limestone and sandstone. These are more likely to contain hydrocarbons than dirty rock. Logging a well is one very effective way to gather detailed information about the different layers of rock that have been drilled through. Logging a well provides greater certainty about whether or not hydrocarbons are present. If the well does not look promising, the process can be stopped and the well plugged and abandoned before incurring the larger costs of completing the well. Using diverse scientific techniques, each tool performs a different kind of measurement of the rock and fluid properties within the geological formation surrounding the well bore. Another helpful technique is to take a core sample of a target zone. The core sample can provide valuable data about the surrounding underground features, formations, and presence of oil-bearing sand. The entire process is carefully monitored by the U.S. Oil log crew and geologists. Once the well has been logged and deemed a commercial well, production casing is then inserted. As with the surface casing, the production casing is also cemented into the hole. Back on the surface, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crews who will ready the well for production. The first of these steps is to perforate or perf the casing. A perforating gun is lowered by wire line to the target zone. An electrical current is sent down the wire line to the perf gun, setting off a charge which shoots holes through the steel casing, the cement, and out a short distance into the target formation. The perf gun is then pulled up from the wire line out of the hole. The next step is to hydraulically fracture or frac the target zone, which was just perforated. Here, sand and water are pumped into the well bore under extremely high pressure. When the mixture reaches the target zone, the pressure forces it out through the perf holes and out into the sandstone formation, causing it to fracture. This creates a fairway connecting the reservoir to the well and allows the released oil to flow to the well bore. Now that the fracture process is complete, hydrocarbons can now flow simultaneously into the well. Next, U.S. Oil installs a permanent well head, pump jack, and other necessary surface equipment such as the tank battery, which consists of a gun barrel tank for separating water from the oil, a tank for water, and a tank for oil. More tanks can be added as needed for increases in oil production or continued development of a lease. The final step is to install electricity to the pump motor and connect an underground pipeline from the well to the oil holding tanks. Once completed, you have producing oil wells. U.S. Oil believes in doing the infrastructure right the first time to minimize future maintenance expenses and to maximize oil production. For more information, please visit usoilpartners.com.